Okay, so it's recording. Let's go ahead and take a look at this. Let's start with this problem, actually. If a function has all positive coefficients, then it cannot have any, and the answer is positive roots. And the reason is this. Let's say you're given a function like this one, x squared plus 2x plus 3, right? A root would be a number that you could plug in, and everything would go to 0. Okay? So now I can imagine that happening if I were to plug in some negative numbers. For example, if you plugged in -1 right now, it would work. It would go to 0. But I cannot possibly imagine that working with a positive number here. It's impossible. Do you guys understand that? It's impossible to plug in a positive number and have this come out to 0. If this is 0, it is definitely true that x is some negative number, see? So it cannot have a positive root. All right, let's go to the next problem. An even degree polynomial might have 4 real zeros, 5 real zeros, 6 real zeros. So which is it? Well, an even degree polynomial would be something like, x squared plus yada yada. Or x to the 4th plus yada yada, right? Okay, now these could have x-intercepts, right? Or maybe none at all. You can tell these two that I've drawn do not even have zeros, right? If we were to shift them down, let's say we move that x squared graph down, we could pick up 2 zeros by shifting it down, see? Same thing with the x to the 4th graph. You could shift it down and get 2 real zeros. In other words, x-intercepts. You can kind of think of that almost as zeros. Okay? Or if you shift this particular x to the 4th graph down a little bit more, you could actually get 4. See? But I can't see how you could possibly get 5 real zeros. You could take a 6th power function like this, y equals x to the 6th plus yada yada. That thing has 5 turning points. 1, 2, 3, 4, 5. And you could shift it down a bit and get 1, 2, 3, 4, 5, 6 x-intercepts. But I can't imagine how you could get 5. How could you get 5? Now you might argue, hold on, Mr. Shore, here's a 6th power function. Cross through, cross through, cross through, cross through, come back up, and bump off the axis. There's your x to the 6th, Mr. Short. 5 real zeros. No, 5 x-intercepts. This still counts as 6 real zeros. Watch. 1, 2, 3, 4, and this counts as double. 5, 6. So it's a double root now, and it's still 6 real zeros. Okay? So an even degree polynomial has an even number of roots, or zeros. Okay? So let's go with 1 and 3. Oops. I meant to circle answer choice D. Let's go down to the next one. If f is a polynomial function and f of 1 is -3 and f of 3 is 1, which of the following must be true? So you just have to understand that this means 1, -3 is on the graph, and this means that 3, 1 is on the graph, and you might as well draw it. Okay? So imagine plotting 1, -3 and 3, 1 on here. And it's very important you read the instructions. It says this is a polynomial graph, which means it's not this crazy complicated sine graph or ln graph. It's just a polynomial. Polynomials are continuous everywhere. They have all real numbers domain. They're smooth everywhere. Okay? So there are many ways to connect from, point A to point B. Maybe like this, or like this, or like this. Okay? Let me do that last one in green. You could follow the blue path, the red path, the green path, right? After drawing this, let's go back and look at which of these must be true. Okay? Is it true that f has to have at least 1 0 between 1 and 3? That means an x-intercept. Yes. no matter what, if you're going to go from A to B, you're going to have to cross through the x-axis. So we can definitely assume that there's at least one x-intercept between 1 and 3. So that's definitely true. Has no sharp turns. No sharp turns. That's not really true for all graphs, but it's true for polynomials. So this is a key word right here. Polynomials are always smooth and don't have sharp turns. So Roman numeral 2 must be true if it really is a polynomial, like it says. F cannot have a maximum point. I disagree. Look at my red graph. That one has a maximum point. See? And that was one of the possible paths from A to B. So I don't think this is necessarily true. What must be true is that it has 1, 0 that crosses through the x-axis, and it has to have no sharp turns, because it's a polynomial. All right, so I want to go with 1 and 2. Welcome to the AP calculus test. Okay, tons of these little Roman numeral type problems. You see these sorts of things on the SAT also. Also, the must be trues, these kinds of problems are testing some deep thinking skills. They're testing you and your ability to interpret the symbols. They're testing to see if you understand that there are multiple ways to get from A to B. It's a great question. It's testing a lot of levels of thinking there. So that's why I like them. They're not halfway problems. You know, they're real thinking problems. So. Okay, let's go to the next one. If a polynomial function has a remainder of 1 when it's divided by x minus 2, then x equals 2 might be a 0, cannot be a 0, might be a factor, cannot be a factor. Well, first of all, this is a factor. X minus 2 is a factor, okay? I'm asking you about x equals 2. X equals 2 is the 0 for the factor x minus 2. See? So it can't be anything that says factor. X equals 2 is not a factor. X plus 2 is a factor. X minus 2 is a factor. See? Okay. Now, what is true about a true 0? If a number is truly a 0, then what would the remainder be?
0.
The remainder should be 0 if it's a factor, or if it's a root, right? Well, the remainder is 1. It says right here. So it is not a 0. It can't be a 0, because then the remainder would have been 0. So that was almost a vocab question. Do you know the difference between a 0 and a root factor? See? Which of the following polynomials has x equals negative 2 as a 0? You could just plug negative 2 into each of these. The first case, you get 32 plus 40 minus 24 minus 40 minus 8, which is exactly 0. And so this definitely works, okay, because it gave us 0. Then you can plug negative 2 into this next one, and you get 32 plus 8 minus 17 times 4 is 68, minus 32 plus 12. See, this is not 0. That didn't work. And then you could try this one, 32 minus 88 plus, then 18 times 4 is 72, plus 8 minus 8, no. It looks like only Roman numeral number 1 gave us 0 when we plugged it in. All right? All right, let's go to 8. Let's go to number 5. I'm sorry, number 6. If k is an integer, which of the following is not a possible rational root? So this problem really threw people for a loop. People thought that they were supposed to find k, but the truth was, the key to this problem is understanding this phrase. Possible rational root means p over q. This means p over q, and p over q means possible rational roots. It's a key buzz phrase. You're supposed to know what that means. So all you have to do is do p's and q's. So the p values on this problem are the factors of 6. 1, 2, 3, 6. The q values are the factors of 4. 1, 2, 4. And if you take the time to make a detailed p over q list, you get 1, 2, 3, 6. You get 1 half, 2 halves, 3 halves, 6 halves. I'm not writing down the 2 halves and 6 halves, it's redundant. I already have those. And you get 1/4, 2/4, I'm not going to write that. 3/4, 6/4, I'm not going to write that. Some of those were redundant. But what I'm saying is, even with the pluses or minuses included, I don't see 2/3 in here. I don't see it. It is not a possible rational root. If this polynomial has roots, and they are nice numbers like 2/3, one, or I'm sorry, like 4/5 or 8/5 or something like rational like that, 2/3 is not an option. I could tell from the first and last coefficient. I don't need the k for this problem. The k was there. The reason I put the k there was because I didn't want to put a number there, or you might feel like you should solve for it. Like actually try all these answers. And I don't want you to do that. But just to think about which one would not ever make sense. So k could be 1,000,000 and 2/3 is still impossible. Let's go to the next problem. Suppose a polynomial function has 2 rel mins and 2 rel maxes. So you could just kind of sketch that out. Imagine having a max and a max and a min and a min. And imagine trying to connect that. And you're not allowed to have any more or less. This is it. You could tell that this thing is odd, can't you? You can tell it's odd. Look at the arrows. It has odd end behavior, see? So if it has odd end behavior, then it has an odd degree. So it could be a 5, it could be a 7, but it couldn't possibly be a 6, or it would be arrows up. And there would be 5 turning points. All right, next is, oops. Let's go down to number 8. Toby used synthetic division to see if x equals 3 was the 0 of the polynomial. He got the following. 2, 1, 12, 17, 46 for his quotient coefficients, and 168 for the remainder. Briefly explain why Toby should not continue trying synthetic division with any value greater than 3. Okay, so what's going on is he did his synthetic division, he got to 3, and we don't know what the original coefficients were, but this is what he got, 2, 1, 12, 17, 46 with a remainder of 168. He should not use any numbers bigger than 3 because it is already impossible if 3 didn't yield a root and it has a positive remainder and all of these are positive. It's impossible for him to plug in a number like 4 or 5 or something bigger to make this go to 0. That's impossible. So we were saying back in number 1, if a polynomial has all positive coefficients, it could never go to 0 unless there's a negative in there somewhere. So you can't plug positive numbers in and expect it to go to 0. It's not going to happen. So you have to figure out a way to write this. Did anyone get full credit on this? What did you write?
Since all coefficients of x divided by x minus 3 were positive, Toby shouldn't try to use any values greater than 3 because they will not yield a remainder of 0 or a factor. Instead, the remainder will increase as the 0 increases, especially since the remaining larger zeros are factors of 3.
Okay.
I got very small at the end because I was trying to fit it in.
That's okay. You probably didn't need to write that much, but it's good. I mean, pretty much everything you said sounded pretty true. I wasn't listening too carefully. I was trying to write at the same time. But the first clue is all the coefficients are positive, and the remainder's positive, right? So if he goes any bigger, what's just going to happen is all the numbers are going to accelerate bigger. So it's just going to get worse from here. Everything's going to be even more positive. And so I like the phrase you had where you said the remainder will continue to increase, right?
Yeah, instead the remainder will increase as the 0 increases.
Yeah, or the test value, the synthetic division value that you're testing. Yeah, so the remainder will increase as you try higher values of x. In other words, the remainder can't go to 0 if it's already positive 168 and it's getting bigger. Okay, so something like that. I was really looking for the remainder can't be 0. Something like that. Ever. So he's going to have to go try some negative numbers, I guess, in his synthetic division. A quadratic function passes through the points 0, -1, -3, -10, and -2, -1. So here's how I taught you to do this. You just start with the given facts, and these are all x's, and these are all f of x's, right? So you can actually start with writing -1 equals a times x minus h squared plus k. That's the first point plugged in. Then do the same thing with the second pair of numbers. -10 equals a times -3 minus h squared plus k. And then do the same thing with the third set of numbers. -1 equals a times -2 minus h squared plus k. And I strongly suggest you make sure the x and y are in the right spot. Okay? And then you can see here there's a golden opportunity to get rid of k. So let's subtract these first two equations. We'll subtract them. And k will drop out. That's good. So we have basically -1 take away -10. So that's like adding 10. So this side is going to be -1 plus 10. So that's 9. And then you're just going to have all this garbage. The k is now gone. All right, so we have basically 9 equals a times 0 minus h squared minus a times -3 minus h squared. But they both had an a, so I'm going to pop that out like that. So I keep the a on the outside. And then I'm going to do the same thing with these two. Just subtract them. This time it's -10 minus -1, which is -9. The k is gone, as before. And we have -3 minus h squared minus -2 minus h squared. So I did equations 1 and 2, equations 2 and 3, just subtracting straight up. I also took the a out front. Now, like magic, watch. I'm going to divide these equations. And a is gone. Goodbye, a. Good riddance. What we have is this. -1 equals 0 minus h squared minus -3 minus h squared over -3 minus h squared minus -2 minus h squared, which looks really awful, but it's really not that bad. In fact, there are no h squareds. If you FOIL this out carefully, you get h squared minus 9 plus 6h plus h squared over 9 plus 6h plus h squared minus 4 plus 4h plus h squared. All the h squareds cancel out. So this thing is completely linear. It's really a basic problem. It's just basically -6h minus 9 for your numerator. And it looks like we have on the bottom 2h plus 5 or something. And this is equal to -1, so you can just kind of cross multiply it. Okay, so you end up with -6h minus 9 equals -2h minus 5. And you can add the 9 over, add the -2 over. You just end up getting h equals -1. After you have h, you can go back and find a. Anyone care to tell me if you have h and you need a, which equation on the board might be a good choice? If you have h and you need a, don't just go back to the beginning, you know. Any of these things you wrote are true, so where might be a good one to look? One of these guys maybe, right? Because these have a's and h's. So now that you know that h is -1, you can easily find a. Just maybe use that one, or that one's your choice. After you have both a and h, how would you find k? Take a pick. Okay, now you want to see a really frustrating thing about this problem? You could have gotten the h in 2 seconds. You ready? I designed this problem where a student paying attention would realize that I gave them this point, and this point. Two of these points have the same y coordinate. See them side by side? Isn't this just a parabola? Isn't the axis of symmetry right here? It has to be. The axis of symmetry has to be right there. Isn't h -1 just because? Well, there you go. Don't need any of that. Okay, so this method that I showed you here is fantastic for any 3 points. Okay, it's great. In this problem, you could have gotten away with a little sketch, and you would have known right away h of -1, and you could have gone back here to find a and k. All right. So anyway, that's what's frustrating is how easy it could have been. All righty. Next time, right? Watch out for. Always think about the graphs of things. You know, don't just jump into the algorithm. Okay, now I felt a little bit bad giving you this problem because I didn't test you. I didn't give you much homework on this topic.
Yeah, why
Okay.
did you also go from 12 to 10?
Huh?
Why did you skip?
Did I
10
skip a problem?
And you went, no.
No, you went from
It was
9
9 to 12 to 10.
I don't know. Is your test that way too?
Yeah.
I have no idea. Okay, let's go to 12. And I felt a little bad giving you this problem, but I thought, you know what, I'm going to make it really clear what to do, and I'll see if the students bother reading it. Or maybe they'll just see, oh, word problem, skip. Okay? Oh, fraction. Oh, skip it. There's a fraction right there. I'm not doing it. This is what students tend to do. Psychologically, they're like, I'm not doing this problem yet. I'll come back to it later. It's too hard. But if you read it carefully, it tells you exactly what to do at all times, which makes it easy in the homework problems. It says right here, the price is, here's your price function. There it is. Okay? It says right here, the revenue is x times p of x. I gave you p of x. It's right there. There's p of x. Multiplied by x. That's what it says. It says x p of x. So multiplied by x. All right, so what happens is you just take my price function and you multiply it by x. Done.
Oh, you didn't want to, no, you wanted to distribute it more though.
I don't care. Put an x in. Fine. If you want to, you could have written the answer like this. I'd give you full credit. X times -1/3 x plus 8. You could have just read the question. It says multiply p of x by x. That's all it says. Are you willing to read? Okay? All right. Now, the next question gets a little tricky. It says, what quantity x maximizes revenue? But then I put, consider the vertex. Let's just find the vertex, because that's where the maximum occurs anyway. Maximum revenue. Okay, so let's play around with this for a minute. So we have this new function. We just created it. I want to maybe complete the square, get the vertex figured out, or I can use that little cheat, -b/2a. That works great. I'm going to go ahead and do completing the square. So I'm going to pull out the -1/3. That's going to make this a -1/3 times x squared minus 24x. All right, and now I need to add the magic number. What's half of 24? 12, good. And squaring that, we get 144. I just put in a brand new -1/3 of 44. So I need to put in a positive 1/3 of 44 to keep it balanced. 144, excuse me. In other words, I need to put in a brand new 48. Okay, so this comes out to -1/3 x minus 12 squared plus 48. Don't let this scare you. This is a revenue function. What is revenue? I don't know. Who cares? Who cares? I know its vertex is at 12.48. I know revenue has something to do with money, so this is like dollars. $48. What x maximizes the revenue? 12. What is the max revenue? $48. Watch this question. What is the price? $4. Why? Because x times p is r. X times what is 48? 4. Or you can take 12 and plug it into the price function because they asked for the price. So are you willing to read and just follow the directions? Even if it's during an anxious moment like a test. None of these problems were hard, especially with the clue, consider the vertex. Okay? And if you really did do your homework, okay, and you didn't just go online to Slater or get answers from someone else or bust out the graphic calculator every single time, you have seen this problem 4 or 5 times before the test. Because it was in the review, it was in the homework, you should be practicing extra problems anyway. All right, so there it is. And then this stuff, you guys did great. You did really well. What is the degree? You've got x times x squared, so that's degree 5. What are the x-intercepts? Everything's clearly factored, so we have negative 5 halves, 3 halves, and 3. At what value does it cross the x-axis? So that would be at the negative 5 halves because of the odd multiplicity. At what values of x does f merely touch the x-axis? That's the even multiplicity ones. So that would be the 3 halves and the 3. Determine the end behavior model. So for that, you can just forget the plus 5, forget the minus 3, forget the minus 3. Just look only at the x's in this problem, and you can see that it's 8x to the 5th. Okay, so a nice end behavior model would be 8x to the 5th. It's also the first term you get if you bother to FOIL the whole thing out. If you really multiplied it all out, it starts with 8x to the 5th plus yada yada. Then we can do, as x gets big, y does what? Well, if it's an x to the 5th, then it should look like this, technically. So as x goes to infinity, negative infinity, y goes to negative infinity. As x goes to infinity, y goes to positive infinity. What is the y-intercept? For that, you should know that you can make your x's 0. So just imagine scribbling this out. Be careful though, it's 5 times 9 times 9, okay? 5 times 9 times 9, which is what? 5 times 81 is 245, right? No, what am I saying? 405. You just have to be careful. It's 5 times 9 times 9, right? What is the domain and range? It's a polynomial. Domain is all real numbers. It's also got this one arrow down, one arrow up look, so it should have range all real numbers. Sketch the graph. Okay, so we will need some x-intercepts. We know that at negative 2.5 we have an x-intercept, and at 3 we have an x-intercept, and at 3 halves we have an x-intercept, and it's a touch point at 2 of these spots. There's an arrowhead here, but this right here is a crossing point. The other 2 are touch points, so it's going to come down and touch, go up, come back down and touch, and go off to infinity. Close enough. Okay? Sketch it. Don't worry about the position of the relative extrema. So don't worry about the peaks. All right? Next problem is this one. Now this is a parabola, so you can actually just completely solve it. Just pull out the negative 2. And then you're going to need to complete the square by adding a 4 here, but it's under the influence of that minus 2. So you have a brand new negative 8, you need a plus 8 here. Okay, so my function is, and I think that was worth my time, negative 2 times x plus 2 squared minus, or plus 7. I like that I did all that hard work, because I'm going to have a really easy time graphing. My vertex is at negative 2, 7. It opens down. It has a y-intercept of negative 1. You can tell from the c value at the very outset of the problem. My axis of symmetry is right here. I get a point for free on the left of the, on the other side of the axis of symmetry. And 3 points is pretty much good enough to get a good sketch going. Now I'll answer my questions. Find the vertex, negative 2, 7. Determine if it has a max or min. That's a max. Explain the parabola opens downward. Do you guys want a better word for that? A more mathy word? Okay, guys, new word is concave down. Okay, we will use this word for all other graphs. So you can't say opens downward for a cosine graph, but you can say concave down. So opens downward, our new word for that is going to be concave down. Okay, concave up like a cup, concave down like a frown. Find the axis of symmetry, that's just x equals negative 2. Find the x-intercepts. For that, you're going to need x equals negative b plus or minus square root of b squared minus 4ac.
All over 2.
Yeah, all over 2a. So just be careful. This is 8 plus or minus And it's root 56, which is 4 times 14. So you could pop a 2 out. And please, please listen. Everybody, please listen. I am seeing so many people simplifying this wrong. Okay? If you want to reduce this, everybody, listen, please. Eyes up here. If you want to simplify this, please be careful to factor out the 2 on top. And then reduce this to a 1 and a 2. Please, please, please. Okay? The answer to this question cannot be simplified beyond this. The answer is 4 plus or minus root 14 over negative 2. Some of you guys got too carried away with simplifying. 4 plus or minus root 14 over 2. Negative 2. Okay? So many of you are doing this, it's ridiculous. And my calc students do it too. As soon as they get to the quadratic formula, they go like this. No! Stop doing it. Okay, you cannot cross out this 8 and 4. You can't do it. You can't cross these out. Ever. You factor out a 2, you reduce. That's all you can do. There's no such thing as canceling in math. It's always factor top, factor bottom, cancel. Right? Would you do this if I gave you 5 plus 15 over 5? Would you cross out the 5s? Of course not. But you guys do it all the time on my quadratic formulas. I see it on every exam. Stop doing that. Thank you. All right, so awkward X-intercepts, they usually are, especially when the vertex is friendly looking. So it's basically 4 plus or minus root 14, all divided by negative 2. Domain, all real numbers. Range, looks like y is less than or equal to 7. Sketch the graph, I already did. Okay, next is this one. Please don't shy away from bonus problems. Some teachers don't even put them on their tests because they're afraid the students won't read them. The truth is this is very, very doable. Okay? Average rate of change is and always will be f of x2 minus f of x1 all over x2 minus x1. It's always meant that. Okay? Now you don't have the function, but you have the picture of the function. That's the next best thing. The x1 is clearly 0. The x2 is clearly 3 pi over 2. So we're trying to do f of 3 pi over 2 minus f of 0 all over 3 pi over 2 minus 0. That's what we're trying to find. F of 3 pi over 2 would be evidently negative 2. F of 0 is evidently 0. That's the y-coordinate. So I get negative 2 over negative 3 pi over 2. In other words, 4 over 3 pi. And that's the answer. Now I ask that you would sketch a secant line that corresponds to this average rate of change. What was I talking about? I just wanted you to go like that. That's all I wanted. Just go like that. Does anyone know what this number is? Now, if you just drew the line, I didn't give you credit. You had to draw the line and give an answer like I did.
No, yeah, but you put that it was negative on mine.
Oh, it is negative. Hold on. I got an error here somewhere. F of 3 pi over 2.
3 pi over 2 isn't negative.
3 pi over 2.
Oh, it's
Oh, I don't know why I put this. I'm sorry, right here. I see my mistake. This is a plus. I have no idea why I changed it to a minus. It was a plus here. Okay, so this is positive. This is a negative answer. But what does this number mean? Does anyone know? I've got this little line. I've got my A rock.
Slope?
It's the slope. Yeah, that is the slope of this line. So the slope is negative 4 over 3 pi. That's what it means. Average rate of change has always meant slope. This is really just y2 minus y1 over x2 minus x1. That's all it is. This is a very doable problem. Okay, so study it again at home. And then I think we're done with that test.